Paying attention and you know what each of the terms mean. So today we're going to start with perpendicular bisectors and angle bisectors. And both of them are bisectors. What does a bisector do? Splits it into equal parts, right? So we already know what a bisector does. Well, now we have a perpendicular bisector and then an angle bisector. Okay, so I think you'll be able to tell the difference between the two. All right, so a perpendicular bisector of a triangle is a line or a ray or a segment. Okay, so this can be a line with arrows, it can be a ray, or it could be a segment that is perpendicular to a side of the triangle at the midpoint of that side. Okay, so again, this is my symbol for perpendicular. So what we're going to do next is actually draw in these perpendicular bisectors. That's why I gave you a protractor. Okay, so today we're going to learn how to draw in a perpendicular bisector with a protractor. And next week we are going to learn how to draw in a perpendicular bisector with a compass. So we'll be doing constructions with those. If I don't have enough protractors, you'll have to share with somebody. I don't know if I have enough, but if I don't, just share with somebody at your table, please. So we want to draw the perpendicular bisector of segment AB. So what you're going to do first is take that like ruler end of your protractor or the straight edge portion, and you want to line it up with segment AB, and you want to count how many dashes are between the 2 points. Okay, so this first one here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14-ish, right? Yes. Now to find the midpoint of that, you're just going to cut it in half. Okay, then don't use it. Okay, so I'm going to cut that in half then. So that'll be 7. So I want to make a point on line AB at that 7th dash mark. Okay, so I have my midpoint now. To create the perpendicular, your protractor has this open circle in it. Okay, you want to place your midpoint and that open circle over top of each other. And you want to make sure that you're lining up that segment coming off of that open circle with your segment. So if it's sideways like this, you can see it's not lined up. You want to make sure that segment there is lined up. Now since this is perpendicular, we want it to be 90 degrees. Well, this line that comes off of that open circle is 90 degrees. So we're going to place a point right above that. Okay, now that I have 2 points, I can just connect the two with my straight edge. Okay, now these two pieces are going to be congruent, and that line I just drew in is perpendicular. That is what your perpendicular bisector looks like. Okay, we're going to do it for the next triangle as well. So again, first step, line up that ruler end. You want to count your dashes, keeping in mind if you have a protractor like mine, there are 16 smaller dashes before you hit that larger numbered one. Okay, so I have 16 to here, 17, 18, 19, 20, 21-ish. Okay, so I have about 21. Divide that in half. That's 10.5. So I want to count 10.5 dashes to place that midpoint. Okay, so now I have my midpoint of AB. Your next step, take your open circle, place it on that midpoint. Line up the segments. You want to make a dot to where that perpendicular is off that open circle. And then you can connect your 2 points with your straight edge. Okay, and then I can label my triangle. Since I had a midpoint, I have my two segments there congruent, and I drew in a line perpendicular to that side. Okay, last one, you're not doing the bottom line like we just did. You're doing this line, AB, going sideways here. So again, you still just want to count, because first we have to find that midpoint. So I have about 17. Okay, so that's 8.5 for the midpoint. Again, then we place our protractor, our open circle on our midpoint, line up those segments, place a dot where that perpendicular line comes off of your open circle, and then we want to connect the two with our straight edge. Okay, then I have congruent segments there and a perpendicular. Okay, keeping in mind for a perpendicular bisector, this does not need to go through a vertice of your triangle. So this one came close to going through that vertice. This one didn't. Okay, so your perpendicular bisectors don't need to go through a vertice of your triangle. It's just perpendicular to that side at the midpoint. Questions on what it looks like or how to construct it with a protractor? All right. Next we have some vocabulary terms. So the first one is concurrent lines. These are 3 or more lines that intersect at the same point. Okay, so 3 or more lines. So here if I have 1 line, 2 lines, and then a 3rd line, they all have to intersect at that one specific point. Okay, those are concurrent lines. That means the point of intersection, okay, so this time I'm talking about the point. That point of intersection of your concurrent lines is called the point of concurrency. Okay, I'm going to say point of concurrency throughout all of chapter 5. So you have to know what the point of concurrency is. It's where all 3 of your concurrent lines intersect. Now, perpendicular bisectors do have a point of concurrency when you draw in all 3 in a triangle. Okay, so that point of concurrency for perpendicular bisectors is called the circumcenter of the triangle. Circumcenter. Okay. Leading into your perpendicular bisector theorem then, that states if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. Okay, meaning it hits at the midpoint. Okay, so if your point is on the perpendicular bisector, you have a point on that bisector of that segment, then it's equidistant from your endpoints of that segment. So it's just saying it's at a midpoint. The converse of that, so again, converse meaning backward. Okay, so if a point is equidistant from the endpoints of a segment, then it has to be on that perpendicular bisector. Okay, so it's just the backwards of that first theorem that we went through. And equidistant meaning the same distance. Okay, we also have a circumcenter theorem. It states the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of that triangle. This point is the center of a circumscribed circle. Okay? A circumscribed circle is a circle around the outside of your triangle. Okay? So that circle will be on the outside, and it's going to hit all of the vertices of your triangle. Okay? So just to explain this theorem a little bit better, what we're going to do in the triangle below is actually draw in all of your perpendicular bisectors like we did those first 3 problems. So you don't need me to go through this whole thing. Take your protractor. For each and every side of that triangle, you're doing what we did up here. So count the length of that side, find the midpoint by dividing it in half, and then find where it's perpendicular. Okay, so placing that open circle on your midpoint and finding that perpendicular for all 3 sides. So you should do it 3 different times. I'll tell you why once you do it. And again, keeping in mind when you hit one of those bigger numbered sections, that's 16. So if I have 2 of those, that's 32. And then you can count from there. Make it a little bit easier on yourself. When you're drawing in your perpendicular bisectors, make sure you extend it all the way. Don't just connect the 2 points. So extend through the other side of your triangle. That's nice. You should notice when you draw them all in that they do intersect at one point. Again, that's called your point of concurrency. They should all be intersecting at that one point within your triangle. All right, with these then, they are all perpendicular to the side. So you can label that, all perpendicular to that side. They also hit at that midpoint. So I can say each of those pieces are congruent to each other as well. So just labeling each of those. Now, I wanted to have you draw these in so I can better explain that circumcenter theorem to you. So this point where they all intersect right here, is your circumcenter. Okay? That point where they all intersect is the circumcenter. Now, what that theorem is saying, if you connect your circumcenter to a vertice, so each of these vertices here, so that line, your circumcenter to another vertice right here, that segment, and then the last one, this segment right here, my pen will work. All three of those segments are going to be congruent to each other. Okay, so from your circumcenter to each of those vertices, my pen just died. Each of those, this one's going to die too, that's great. Each of those segments are congruent. Okay, you don't have to do this part, but I'm going to tell you why they're congruent. So if I were to draw in a circumscribed circle, and I'm going to use my nice compass here. Okay, if I were to draw this in, lots of paper. These are congruent because they're each a radius of that circle. Okay, so that circumcenter is the center of a circumscribed circle. That's why each of those vertices hits that circle. Since it's the center, then each of those pieces are a radius, and all of your radii are congruent within a circle. Okay, so that's why that theorem works. Does that make sense? And yes, you'll be able to use the compass next week, and you'll be able to draw in those circles as well. Okay? Questions on your perpendicular bisectors? Constructions.
I don't have to draw this on the test, right?
Maybe.
If I do, I'm skipping that.
No.
Yeah.
Okay, so next then we have an angle bisector. So we just went over perpendicular bisectors. Now we have angle bisectors. So the angle bisector of a triangle is a ray. Okay, it is a ray, not a line. Ray that divides each angle of the triangle into two congruent angles. And yes, we had these in our proofs. If I gave you an angle bisector, you knew those two angles were congruent. That's what we're doing. So we're going to draw in the angle bisectors of each of these triangles from vertice A, and we're going to use our protractor again. So for this one, you're going to take that open circle and you're going to place it on your vertice A. Okay, I forgot I was going to give you rulers for this part. To find your angle bisector, you need to figure out how large your angle actually is. So you need to line up that bottom segment from your open circle with the segment on the bottom of your triangle. Okay? And again, I forgot to give you rulers. And then you need to see where that angle hits your protractor up here. Okay? So for this one, you're going, for mine, I'm going to use the numbers on the bottom. Okay, because it is an acute angle. You can tell it's an acute angle, right? And I want to say it's about 55 degrees, 56 degrees. Okay? Then I want to divide that by 2. Okay? You're finding the angle bisector. What does a bisector do? Splits it in half. So I found the angle measure to be 56, right? So I'm going to take 56 and divide it by 2 to find that angle bisector. Well, when I divide 56 by 2, I get 28. So I'm going to find where I have 28 along my side here. Well, this is 20. This is 25, 26, 27, 28. I'm going to place a point right above where that 28 is. Okay?
That is so far up though.
Yeah, I know. You're not going to connect it all the way. So I'm going to place my straight edge where angle A is to the point I just made. Now again, I just want to cross through that opposite side. I don't actually need to connect it to that point. And then make it a ray. Okay, and I can mark those two angles congruent then. Okay, we're going to do the same thing with the next one. So again, first step, you want to place your open circle on vertex A. Line up your segment. It is 90 degrees. I'm going to take half of that because it's a bisector. So 90 divided by 2 is 45. So I'm going to follow my numbers here. I hit 40. 45 would be this one right here. So I'm going to place a dot right above that 45 marker. Okay, then I want to place my straight edge on my vertex to that dot I made. And again, all I have to do is cross over that opposite side. And then I can mark those two angles congruent. Again, your angle bisector doesn't need to bisect the side, just the angle. Okay, last one. Same thing. Open circle on your angle. Line up that bottom segment. We want to see where this angle goes to. 72-ish. Right?
Yes.
So 36 would be half. So it is off the page. So I'm going to go to 30 to 5 to 36, and I'm going to estimate here
What is it? 30 what?
36. And I'll place it right underneath over here. Then again, I just need to connect those two dots. Cross over that opposite side and mark my angles congruent.
I'm dying.
Okay, when you use a compass next week, this will be more exact than with your protractor. Okay, so that's what you'll be using instead of the protractor, but I just want to show you how to do it with the protractor as well. Any questions on using your protractor to draw in an angle bisector? Find the angle, split in half, mark where that is, connect the dots. All right, so just like with a perpendicular bisector, we do have a point of concurrency of all three angle bisectors in a triangle. Okay, that point of concurrency is called the incenter of the triangle. Okay, so where all three angle bisectors meet is called the incenter. We also have an incenter theorem, just like we had a circumcenter theorem. That states the angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. Okay, the incenter is the center of an inscribed circle. Okay, this inscribed circle is inside your triangle. Okay, so that circle's inside, our last circle was outside. So just like before, with our perpendicular bisectors, we drew in all three in a triangle. We're going to draw in all three angle bisectors in this triangle. Okay, so take your protractor. You have to do this 3 times. Line up your angle. Find its angle measure. Divide it in half.
Serious?
And connect. Yep. Make sure you cross over to that opposite side then. Okay, I did one angle. to do this angle, I'm going to use the numbers on the opposite side. So I flipped my protractor here. You still want to line up your segments. Okay. Since my triangle is long enough, make sure it lines up with that second segment there. Okay. Then I'm going to connect up here. I'd say about 48 degrees for this one. Okay. So divided by 2 is 24. And then connect. Okay, now this last one is sideways, but you still want to line up, open circle on your angle, line up that segment there, and then follow your line to where it intersects. Okay, I'd say this is about 85 degrees. Okay, yes, your dot is down here. You're doing the same thing you did 3 times above.
Doesn't mean I'm smart, okay?
You are, you can do it.
Oh, bet.
Okay, and again, all 3 should roughly intersect.
Did you say 40 or 45?
For the angle? It's like 41 and a half or 42.
Yes, miss.
All right, so relax. So here I have my point of concurrency. Okay, that point is your in-center. So where all 3 of your angle bisectors intersect. Okay, now with your in-center, it is the center of a inscribed circle. So I'm going to try and draw in your circle again. This one never works out for me very well. When I do that, according to your in-center theorem then, okay, from that point of concurrency to the sides, okay, to the sides of your triangle there, those would be congruent. It is a perfect circle. So this length right here, this length right here, and this length right here are all congruent to each other. Okay, so from that in-center to that side, each of those lengths should be congruent. Okay, so if I said this length right here is 10, this length would also be 10. Okay, because each of those are a radius of that inscribed circle. That's what your in-center theorem is talking about. Okay, from the side to that point of concurrency, that length is congruent. Okay, questions on this one? You will not. We are going to practice. No, we're going to practice it a lot. I'm telling you that right now. So what we want to do in these next 2 problems, okay, we want to find each of these measures, okay, using our in-center theorem. So we want to find xy. That's this length right here. Since this is an angle bisector, because both of these are congruent, okay, those are equidistant to each of those sides there, meaning xy is 7. Okay, so They are equidistant when that is an angle bisector. Okay, another way to tell is think about your congruent triangles that we did last chapter. These two angles are congruent. These two angles are congruent. And they have a common side, right? That would be angle, angle, side for triangle congruency. Since your triangles are congruent, well, so are their pieces. So if you need to think about it that way, think about it that way. Find your congruent triangles, then those pieces are congruent. We can do the same thing in number 2. Okay, so J, K, L. These two sides right here are equidistant from that angle bisector, meaning it is an angle bisector. Okay, so those two sides are equidistant from that ray. This is an angle bisector, so those two angles are congruent. And again, if you need to think about it with congruent triangles instead, you can. So in this one, you have a right triangle here. You have a leg, and then your hypotenuse would be congruent to itself, so this would be congruent by hypotenuse leg. Okay, so those two angles must also be congruent. So JKL is 37 degrees. And you do just have like 3 problems on your assignment like that one. Okay, so any questions?